Okay, question 11. So this question is an amount of substance question. It's one of the last questions in paper 1, and it's a fairly complicated question. So what I'm going to try and do is explain first of all what's going on. So this might be a question that you read a couple of times. It's worth 8 marks. You've got some stuff that you can scribble down to organise your information. What I would always say is that no one should leave this question blank. What you must do is you must think, well, what can I do? And start doing some of that. So you can work out the number of moles of some stuff. You can always do something in one of these questions. So let's just have a look then. So this question is about compounds containing ethanedioate ions. So it says a white solid is a mixture of sodium ethanedioate, ethanedioic acid, and an inert solid that we don't know. So inert means that that's not going to react, so we don't need to worry about that reacting. The volumetric flask contained 1.9 grams of this solid mixture in 250 cubic centimeters of aqueous solution. Okay. 2 different titrations were carried out using the solution. In the first one, 25 cubic centimeters of the solution were added to an excess of sulfuric acid in a conical flask. The flask and contents were heated to 60 degrees C and then titrated with 0.02 mole per cubic decimeter of potassium manganate. When 26.50 cubic centimeters of potassium manganate had been added, the solution changed colour. The equation for the reaction is that. So, in this reaction here, the manganate is reacting with ethanedioate ions. So those ethanedioate ions are going to come from the sodium ethanedioate and the ethanedioic acid. So this first equation here is going to give me the total moles of ethanedioate ions in the solution. So it's coming from those 2 substances there. Okay, read on. In the second titration, 25 cubic centimeters of the solution were titrated with 0.1 mole per cubic decimeter sodium hydroxide using phenolphthalein as an indicator. The indicator changed colour after the addition of 10.45 cubic centimeters of sodium hydroxide solution. The equation for this reaction is this. So in this equation, titration number 2, only the ethanedioic acid, H2C2O4, is reacting with potassium hydroxide. So titration number 2 is going to give me moles of H2C2O4 only. Okay, now from that I'll be able to work out the moles of sodium carbonate because I've got the total moles of ethanedioate up at the top. Okay, but before we do any of that, let's read on. Calculate the percentage by mass of sodium ethanedioate in the white solid. Give your answer to the appropriate number of significant figures. Show your working. Okay, so oh my word, you're probably thinking, well, where do I start with this? So you've got to start somewhere. So let's start with titration number 1. And in titration number 1, what everybody can do in here, because you've got it given in the question, you can work out the moles of manganate ions that you've got in the solution. So just go back and have a look at some of this information. We've got that volume 26.50 and it was a 0.02 mole per cubic decimeter. So I'm going to use my lovely equation here, N equals CV divided by 1000. So my concentration was 0.02. Don't forget to put that 0 after the decimal place in. Multiplied by 26.50 divided by 1000 gets me 5.30 times 10 to the negative 4 moles. Okay, that gets me 1 mark. So everyone can do that. You might not have a clue where the answer's coming from yet, but everybody can do that. Then what I'm going to do from that is I'm going to work out the moles of my ethanedioate ions. Moles of C2O4 2 minus. I've got to look at the ratio in the equation. So I've got 2 manganate producing 2 manganate, sorry, reacting with 5 moles of ethane diorate. So I need to take my moles of manganate, 5.3 times 10 to the negative 4, times by that ratio, so 5 over 2. It's 5 moles of ethane diorite reacts with 2 moles of manganate. That gets me 1.325 times 10 to the negative 3 moles of my ethane diorite, and I've got another mark if I've done that. Okay, so that was in titration number 1. In titration number 2, what can you do? Well, you can work out the moles of sodium hydroxide, or the moles of hydroxide that we use. I'm going to use the same equation as before, concentration times volume. So what have I got? I've got concentration of 0.100 times my volume of 10.45 divided by 1000. That gets me 1.045 times 10 to the negative 3 moles of sodium hydroxide, or hydroxide ions. From that, I can then work out the number of moles of acid. So I've got 2 hydroxides reacting with 1 acid. So I need to essentially half that number. Let's just write that out. Moles of H2C2O4 is equal to 1.045 times 10 to the negative 3 divided by 2, because 2 moles of hydroxide react with 1 mole of acid. So that gets me 5.225 times 10 to the negative 4. That gets me 1 mark. So all I've done so far is I've just worked out number of moles of stuff from the information given in the question, and then use that to work out the number of moles of what it's reacted with using the ratios in the equations. I've got half marks. I've got 4 out of 8. So even if you're not thinking, I don't know how to, even if you are thinking, sorry, I don't know how to get to the answer, I know that everybody in here can do that. So give it a go. Okay. So let's just remind ourselves what we've done. So titration 1 gives me the total moles of ethane diorate ions. Titration 2 just gives me the moles of the acid. So essentially what I need to do is do the total moles from equation 1, take away the moles of acid to work out the moles of sodium carbonate that I've got in the solution. So if I look at those two numbers, there they are. So I need to do 1.325 times 10 to the negative 3, take 5.225 times 10 to the negative 4, okay, that gets me 8.025 times 10 to the negative 4 moles of sodium ethane diorate that I've got in my solid. That, remember, is in 25 cubic centimetres of my solution. Okay, I go back and have a look. That was 25 cubic centimetres from a 250 cubic centimetre solution. So, in 250 cubic centimetres, there must be an 8.025 times 10 to the negative 4 times by 10. Which gets me 8.025 times 10 to the negative 3 moles sodium ethane diorate in my 250 cubic centimetre volumetric flask. Okay, so I get 1 mark for working out the moles of sodium ethane diorite in 25 cubic centimetres. I get 1 mark for scaling it up to a factor of 10. Then what I need to do, let me just remind myself of the question. Calculate the percentage by mass of sodium ethane diorate in the white solid. So I need the mass. I've got the moles of it. I need the mass. So I need to use my favourite equation. Mass equals Mr. Moles. I need to work out the MR of sodium carbonate, which is 134 times 8.025 times 10 to the negative 3. That gets me 1.075 grams of sodium ethane diorate in my original solid. I can check that that should be less than my 1.90 that I started with, which it is. That's mark number 7. Mark number 8 is for working out the percentage by mass. 1.75 over 1.90 times 100 gets me bear with me a second. Go not 0.56.578947. Right number of significant figures. Let's have a look at the question. What have I got given in the question? 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 60 degrees. So I could argue here that I'm going to go to 2. So I could give 57%. I think the mark scheme went with 56.6. I think they made a little bit of a mistake with that one. So there we go, but either one of them will be accepted. Okay, so pretty tricky question. What you've got to think to yourself is actually, what can I do? Can I work out the number of moles of stuff? Yes, I can. And if you can do that, then you can get 4 marks. If you do a bit of scaling up, then you're going to get a couple more marks, and then you're nearly there at the end. You might as well have a go at calculating a percentage. So give it a go. Do not give up on those questions.